Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is about an amino acids and the question is in front of you. So the question is, what is the major product of this reaction? The reaction is in front of you and 4 options are provided. Among 4, 1 is the right answer. I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. And don't worry, after some time you'll get the right answer. But remember, self-evaluation is essential for improvement. So that's why you should try. I believe you have tried by yourself, so it's my turn to give you the answer. So you can see this is the reference from where I have taken this problem. So if you look at this reaction little carefully, you can see that this is actually an ester of amino acid, because this is actually hydrochloric salt of hydrochloride salt of amine, and this is actually ester of acid. So this part is amino acid, more specifically alpha amino acid. So its reaction first step is this aldehyde, triethylamine and sodium borohydride. What these indicate? This is reductive amination reaction. So actually this reaction is actually 2 steps. Second is this CDI this. So let's learn everything stepwise. So if you look at the reaction condition, first is this triethylamine in presence of aldehyde, and here this amine hydrochloride salt. So triethylamine is acting as a base, so it will quench this HCl as ammonium salt. So in this way free amine will be generated, and this free amine is capable to form sheep base with this aldehyde, and we know that aldehydes are more reactive for sheep base formation because of Barghi-Dunich trajectory, or in simple words, aldehydes are less bulky, so they can form imine with this amine derivative easily. Now, so in this way, this primary amine will be converted into this imine derivative, and subsequently this imine will be converted into this secondary amine by the reduction of sodium borohydride. Generally, we see that this imine reduction is carried out by this sodium cyanoborohydride, which is actually relatively acid tolerant. Mild acidic condition it can tolerate, and so that's why reaction became easier, because under this condition these amine can be protonated. Okay, so obviously it can have a positive charge, so electrophilicity at this adjacent carbon increases, so that's why reaction happens efficiently. But in this case, how the reaction happens? Because sodium borohydride is actually not acid tolerant. So what happens, based on my understanding, that I believe that it is forming an intramolecular hydrogen bonding with this hydrogen. Consequently, this nitrogen is getting little electron deficient, so the electron deficiency or electrophilicity of this imine carbonyl will be more. Consequently, this hydride from the sodium borohydride will attack as nucleophile and reduce it into the corresponding secondary amine. Now this secondary amine also has a lone pair, so you can see here, and that's why it can react with this reagent named as CDI efficiently. Why? Because this carbon of this CDI is actually electrophilic nature, and amine can act as nucleophile. Not only amine, those oxygen lone pair can also do, because there is a competition between this OH group versus this secondary amine, because this is a little bit bulky, one side ethyl, one side is another part. So now both can attack. So first step they will attack, and whatever you will produce, here I am considering that this amine is attacking here, so it through acyl nucleophilic substitution type reaction, and ultimately it will come back and one imidazole will be left. So in this way what it will produce? It will produce, this is the OH. I am not going to this detail, so this is OH, this is N. Remember, after the nucleophilic attack, student, these nitrogen will be converted in this proton will be eliminated, so this, and here the double bond, and here imidazole. And in the second part, so nitrogen will leave one proton and this imidazole will leave, and the second part, these oxygen lone pair will attack here through intramolecular pathway, means intramolecular acyl nucleophilic type substitution, and these will leave, and ultimately the final product will be produced. In this context, one very important information, why imidazole is a better leaving group. I've already discussed a dedicated lecture on imidazole, but here in very brief, if I say, here the leaving group is, you can consider this is N minus. Imidazole is already aromatic compound, but this anion, nitrogen ion, have some specific stabilization. It can attack and it can open. So the canonical form is expected to look like this is. So this is. Now you can see these two canonical forms are ideal, so that's why it is called equivalent canonical form. Or in physical sense, you can consider that the delocalization of the electron density on nitrogen is very good, means it leaves very efficiently. That's why reaction happens smoothly. So this is the answer of today's discussion. Now, so if we look at the key steps and name reaction associated with this process, first step is sheep base formation. So this is, you can see, this is imine formation. Second, imine reduction by sodium borohydride, and later on workup will produce this secondary amine, and these amine will undergo acyl nucleophilic substitution reaction with this CDI, and ultimately through amide or ester, whatever you can say, this exchange reaction will produce this 5-member means ring derivative. Okay, one side is ester and another side is amide. So this is the product. So answer of today's discussion is this one. Now if this question is given to you, how can you solve less than 30 seconds? In this case, student, I suggest you please do at least the first step. Don't go the tricks at the beginning. So you should know that aldehyde, base and sodium borohydride with these amine hydrochloride salt, what is the product? Reductive amination. So you should write the product from the first step. If you write this, your life will be relatively easy and chances of accuracy will increase. So this is the product. So from this understanding, you can see that nitrogen is attached to an ethyl group. So option A gone, option B gone. Now option C and D. Now this CDI is actually, student, a electrophilic reagent. It is not actually a base. So this option D gone. So what is left? Option C. This is the right answer. So this is the tricks if you have proper knowledge. So this is the overall discussion. Now let's learn what we have learned through this discussion, its conclusion. Because amines are kept as hydrogen chloride salt, because we have seen in the previous case, to prevent the oxidation, because, student, this nitrogen has lone pair of electron. So these could be oxidized by atmospheric oxygen. So in this way we'll get amino oxide or other derivative which we don't want, means actually it's an waste of reagent due to unexpected oxidation, and that happens because of this nitrogen lone pair, and that is blocked by this proton or acid. So after this salt formation, this lone pair actually not available, so it is stable under this atmospheric oxygen condition. Point number 1. And point number 2 is, student, these ammonium compounds are salt in nature, means solid, so they could be stored easily, they could be handled, and whenever you need them, just in presence of base or this buffer solution, you can regenerate those amine and do the reaction. So that's easier. Second, this imine is more electrophilic compared to ester, because this ester has a cross conjugation. What do I mean by the statement? So this is ester, so it can have a cross conjugation, it can push, it can open. So this is the cross conjugation, but if you look at this imine, you can consider them as the analog of aldehyde. So this center is more electrophilic, consequently more reactive in presence of nucleophile. Now next is diimidazole carbonate, or in this case the CDI is actually an amide of imidazole, derivative of, you can say, carbonate ester, or you can say C1 source, and it can undergo exchange reaction with imidazole anion, which is actually a relatively better nucleophile due to aromaticity, because the anion is aromstable. And finally, the intramolecular reactions are highly favored over intermolecular one, and that's why we got that 5-member ring derivative. Okay, so I believe this video may be useful. I am very interested to know your opinion about this channel, and if you consider my contents unworthy, then please help this channel to grow. And if possible, please visit my another channel where I upload global warming and climate change related videos. So thank you.